Hello and welcome. In this video, we are going to look at frequency distribution tables and bar graphs. We need to start with a definition of outlier. I ended the previous video on stem and leaf graphs, and I did not show the definition of an outlier. An outlier is an individual data value that is far away, either above or below, most or all of the other data values. The values can be either extreme values or they could be due to an error. All right, into frequency distribution tables, bar graphs, and histograms. Frequency distribution tables can be applied to both categorical and numerical variables. It can be applied to both of them. Basically, a frequency distribution table is just an organization of the data values and their frequency, or the number of times they occur. So let's start with the definition for frequency. This is the total number of times that a data value occurs within a data set. And a frequency distribution table is a table that divides a data set into distinct groups called classes, along with the number of data values that fall into each class, called the frequency. So again, frequency distribution table, or we don't really need the word table. Frequency distribution is just the table of the frequencies. A frequency distribution table breaks the variables into groups or classes. Again, these variables could be either categorical or numerical, along with the number of times that those data values occur, called their frequency. Let's look at an example here. This example says, a large healthcare facility has noticed that many of its employees have been filing workers' compensation claims. In an effort to address health and safety issues, management of the facility has surveyed 20 randomly selected claims to determine the location of injury. Create a frequency distribution table along with the relative frequency for the set below. And if you look here, we just have a table of raw data values, meaning data values that haven't been organized in any way, shape, or form. We don't know how many of each of these occur. I can look at this list really quickly and see that there's a number of back injuries. That might be one of the more common ones. We'll have to find out. Why would a healthcare facility want to do this? Well, let's say that this healthcare facility or this employer, wants to or has noticed that a number of its employees has been filing claims or been injured on the job, and they are trying to prevent injury in their employees for a number of reasons. It could be insurance claims. It could be they want to make sure that they have enough employees working at any given time. Whatever the reason, they might want to figure out what are the causes of those injuries. So in this case, they survey 20 randomly selected claims, and they want to determine what those injuries are. Maybe they want to implement some new type of training or some new type of device or option for their employees so that their employees don't get injured as often. We can take these injuries and we can group them into their location of injuries. This would be the classes, since we're talking about categorical data, and we can group them using a tally mark. So basically what we're going to do here is we're going to go through our data values, and we will put a tally mark. Oops, that was a bad one. My finger slipped there. We can put a tally mark for each of these values. So back occurs, wrist occurs, hip. And when we do this, basically we're just going to use some old school tally marks. After the fourth tally mark, we're going to use a diagonal to represent 5. This way we can look at them quickly and see how many injuries were at each location. So back now has 5 injuries, so I have made one diagonal. So now we can look at the back injury and see 5 as a group together. Knee, neck, back. Oops, I skipped abdomen. Sorry. Abdomen, back, foot. All right. So these are our tally marks. The tally marks are a quick way of figuring out the frequency. Again, the frequency is how many times do the data values occur. In this case, there are 7 back injuries, 3 wrist injuries, 2 hip injuries, 2 neck injuries, 3 knee injuries, 2 foot injuries, and 1 abdomen injury. We said before that there were a total of 20 randomly selected claims. So we should just confirm that we have 20 here. So 7 plus 3 is 10, 12, 14, 17, 19, and 1 makes 20. So perfect. We have used all 20 of them. We haven't skipped or missed any of them. So this is the frequency table. Again, the frequency or frequency distribution. The frequency is just how many times they occur, broken into their different groups or classes. We could also add another column here called the relative frequency. The relative frequency is just a ratio or fraction of the total. So in this case, we will take 7 back injuries out of a total of 20, 3 back injuries out of a total of 20, 2 out of 20, sorry, that was wrist injuries, 2 out of 20, 3 out of 20, 2 out of 20, and then 1 out of 20. And we can grab our calculator and try to rewrite these instead of fractions. We could rewrite them as decimals. We can do 7 divided by 20, 3 divided by 20, 2 divided by 20, 1 divided by 20. And now we have all of the decimal representations that we can add in here. So this would be the same thing as 0.35. This would be the same thing as 0.15, 0.10. The total here would be 20 out of 20, or 1. We could also write these as a relative percent frequency, which would be just converting these numbers from a decimal to a percent. Convert to percent by multiplying by 100. So 0.35 times 100 would be 35%. This would be the same thing as 15%, 10%, and so on. All right, so that's how we make a frequency distribution, or a relative frequency distribution, or a relative percent frequency distribution. The percents and the decimal representations in the relative frequency and relative percent frequency are relatively interchangeable. You'll see that on the homework. Some questions will want them as decimals, some questions will want them as percents, but they're relatively interchangeable. From here, we can now graph a bar graph for the location of injuries and their frequencies at this healthcare facility. It's going to be a little bit hard for me to show all of this on the same screen, so I had to zoom way out. But basically what we're going to do here is add in our locations of injuries. We will have back, wrist, hip, neck, knee, foot, and abdomen. Now you'll notice that these location of injuries don't have any specific order to them because they are categorical variables, so they kind of go wherever we need them to. Our frequency column, or our frequency axis here, would rather be starting at 0, then 1, 2, 3, 4, 5, 6, 7. Probably spread this out just a little bit. Let's see if I can do this. Whenever we're doing this, we always want to make sure that we have a consistent scale. Which means that the difference between the values are all the same. We want to make sure that we have labels on axes that was badass, axes. And we also want to make sure that we start at 0 on the frequency scale. So we've done that. We have labels. We have a consistent axis, or to the best of my ability. And we have our frequency starting at 0. I will warn you that I am never going to ask you to make me a graph ever. I'm just going to ask you to read graphs. So I'm not all that worried about how we're going to graph these. I just wanted to show you some examples that we can work with. So the back injury occurs 7 times. So we draw a line, a bar at that represents back injuries that goes up to 7. The wrist injuries occurs 3 times. It's generally a good idea to start at the top so that you can see where it ends up. Hip injury occurs twice. The neck injury occurs twice. The knee injury occurs 3 times. Foot injury occurs 2 times. And the abdomen injury occurs once. When I was talking before about a consistent scale, what I also mean by that is that the width of these bars are all about the same widths. Again, I'm never going to ask you to graph any of these on your own. I just want to show you what we should be doing if we were to be graphing these. Now, we could take the same graph and create, or the same set of data rather, and create a relative frequency distribution or relative frequency bar graph using the relative frequencies. So give me a second, I'll do this one in blue. We'll have the same injury locations. I'll use the same order just so that it makes sense with our graph. The order does not matter because these are categorical variables. And I forgot to label this. This is location of injury. I'm going to try and keep these bars the same width so that they're consistent. Our relative frequency scale starts at 0. Notice that I've labeled the axis the relative frequency, and I've now changed this to be the relative frequency bar graph. And the relative frequency bar graph goes all the way up to 0.35, and we'll go by 0.05 just to try and stay consistent. I'm trying my best to keep these the spacing between each of these marks the same. And now we can draw our bars again. Pretty straightforward. Just going up to the maximum height here of 0.35. Wrist goes up to 0.15. Hip goes up to 0.10. Well, I made this one a little narrow. Neck goes up to 0.10. Knee goes up to 0.15. Foot goes up to 0.10, and then abdomen goes up to 0.05. So now we have a visual representation for the location of injuries. We can quickly and easily visualize which one has the highest frequency, which one has the lowest frequency. We can get some information from the graph, from the bar graph, and we haven't really done too much math still. We did a little bit of calculation with the relative frequency, but there's not too much there. All right, so this is what we need to know about bar graphs. A little bit more notes here, and then we'll end this video and we'll jump into a histogram on the next one. Bar graph displays categorical variables as vertical bars to represent the frequency each category occurs. And an important thing about bar graphs is that the bars do not touch. Again, categorical variables do not have a specific order, so we're not going to let them touch because they can be arranged in any order that we want to. Last thing I want to talk about is how we can read a bar graph. If we wanted to, we could look at the foot injury in this one, and we would see that the height, I missed a little bit, the height should be 2, and we could read this as the foot injury has a frequency of 2. So that's how we can draw a bar graph, that's how we can make a frequency distribution, and that is how we can read a bar graph to get information. Thanks for watching.